Hello student, welcome to CH-10 online classes. We all are working from home. Student, in previous video we have discussed about spherical and cylindrical wavefront from chapter wave optics. In this video we discussed about plane wavefront, which is the third type of wavefront. So let's start. Plane wavefront. Student, as we observe cylindrical or spherical wavefront from very large distance, then such type of wavefront called plane wavefront. It means plane wavefront is a special condition of spherical and cylindrical wavefront in which observer is placed at very large distance. So when spherical and cylindrical wavefront is observed from very large distance, then such wavefront called plane wavefront. So draw the plane wavefront. It is a plane wavefront, and the line perpendicular to the plane wavefront is ray. So these are the ray. Similarly, this is another plane wavefront, and these are the rays. Student, to clear understanding about the plane wavefront, consider a spherical or point source of light as we know that this is a spherical source, so it produces a spherical wavefront in this way. These are the sphere. Student, it is clear that as we move away from the source, the curvature of wavefront decreases continuously. Here curvature is maximum, and at that point curvature is minimum. When this distance is very large, then for any observer which is placed at that point, this wavefront appeared as a plane wavefront, not a spherical wavefront. For example, as we know that sun is a spherical source of light, so they produce a spherical wavefront. But when we observe the sun from earth, so the wavefront received by the earth's surface is not a sphere, it is a plane wavefront, because as sun produces spherical wavefront, and when spherical wavefront come towards the earth, its curvature decreases continuously, and due to very large distance, so on the earth's surface it act as a plane wavefront, or the wavefront received by the earth's surface from sun is plane wavefront, not a spherical wavefront. So I hope all of you are clearly understand about the plane wavefront. So please pause the video and note in your notebook. Now student, let's understand what happens when plane wavefront or spherical wavefront incident on any lens or mirror or prism. So firstly discuss when plane wavefront incident on any convex lens. Student, let us consider this is a convex lens and a plane wavefront is incident on this convex lens. Student, as the rays on the plane wavefront is parallel to the principal axis, that's why as a result of refraction from lens, all the rays meet at focus point. So we can say that the refracted wavefront is the spherical wavefront. It means in this situation incident wavefront is plane wavefront, while a refracted wavefront is spherical wavefront. Now in second case we discuss what happens when plane wavefront incident on any concave mirror. When plane wavefront incident on any concave mirror. Student, this is a concave mirror and this is the principal axis of concave mirror. Consider a plane wavefront which incident on this concave mirror. So the rays on the plane wavefront is again parallel to principal axis. So as a result of reflection, all rays intersect or meet at focus point. So we can say that reflected wavefront is spherical wavefront. So in this situation, incident wavefront is plane wavefront, while reflected wavefront is spherical. Spherical wavefront. So please pause the video and note in your notebook. Now let's discuss what happens when a point source placed at the focal point of convex lens. So next condition is when point source placed at focus of convex lens. Then what is the nature of refracted wavefront? We will discuss in this topic. So this is a convex lens and a point source is placed at the focus point of this convex lens. Consider point source or point object O is placed at the focus point of this convex lens. So this is a spherical or point object, that's why it produces a spherical wavefront. And if we draw the rays on this spherical wavefront, so these are the rays on spherical wavefront. As we know that the rays coming from focal point becomes parallel to principal axis. So these refracted rays are parallel to principal axis. So refracted wavefront or nature of refracted wavefront is a plane wavefront. So incident wavefront is spherical wavefront, spherical wavefront, and refracted wavefront is plane wavefront in nature. Plane wavefront. Now understand what happens when the point object is placed on the focus of convex mirror. When point object placed on the focus of concave mirror, so consider a concave mirror and a point object is placed at the focus point of concave mirror. So this point object produces a spherical wavefront and the rays are perpendicular to this spherical wavefront. And we know that the rays from focal point becomes parallel after a reflection. So these are the reflected rays, and we know that wavefront is perpendicular to the rays, that's why the reflected wavefront is plane wavefront in nature. So incident wavefront front is spherical, while reflected wavefront is plane wavefront. So please pause the video and note in your notebook.